Hi guys, today we'll be talking about finding the LHA and the declination for the celestial bodies of the sun, the planet and the star. So we'll take one example at a time. What we are going to learn is how do we find the LHA and the declination values from the nautical almanac for the celestial bodies of the sun, the planet and the star. Let's start by focusing first on the sun. The date is 25th of February 2004 and the GMT time is 2100 hours 16 minutes and 4 seconds. Because it's a GMT time, we don't need to apply any correction to it. We can straight away use this time to obtain the values from the nautical almanac. And the longitude given to us is 076 degrees 24.1 minutes east. Right, so let's find out where we can get the values from. So let's start by finding out the GHA value for 2100 hours of the sun. Alright, so I need to go into the nautical almanac. So if I go into the nautical almanac here for the 25th of February, for the 25th of February here, you can see that that's the date right on the top. And what we have here is on the extreme left hand side is the GMT time given to you, right? We need it for 25th of February. I need it for 2100 hours, right? I need it for 2100 hours. So I need to trace it all the way to the sun. The sun is here somewhere, right? And you can see I just circled it, but hopefully you can see that the GHA and the declination values are given here. Right, you can see that this is the GHA and this is the declination. So if I go down for 2100 hours, I need to zoom in here for you guys. So the GHA value is 131 degrees 43.6 minutes. That's the value I need. So I'll go back into my notes page. So 131 degrees 43.6 is what I have as a GHA value. Now I don't need GHA for 2100 hours. I need it for 2100 hours 16 minutes and 4 seconds, and for that I need to apply a correction which is called the increment correction, and the increment correction can also be obtained from the nautical almanac. Increment pages are normally provided towards the end of the nautical almanac. They are known as increment pages. So if you go into those pages here for 16 minutes and 4 seconds, let's find out what's the increment. So 16 minutes and 4 seconds, I'll go into the increments page here. 16 minutes and 4 seconds. So I need to erase the rest of this stuff so that you guys don't get confused. I've been trying to make this video a couple of times, so that's why all those markings are there. So let's say 16 minutes and 4 seconds. So you've got 16 minutes here. You can see that that's 16 minutes, right? And for 4 seconds, seconds are given here. The increment value is 4 degrees 1 minute for the sun. So you get your increments for the sun and planets from the same column. So I'll go back out now and go back here. So 4 minutes and 1 second is what I have. 4 degrees and 1 minute is what I have here as the increment. So I'll add the increment. Increments are always added. The word itself means addition. So we'll add it, and then we get the GHA corrected value for 2100 hours 16 minutes and 4 seconds, right? With that we apply the longitude. So what we have is the east longitude, and the rule of thumb is that if longitude is east, right, GHA is least. That means GHA will be less than the LHA. If the longitude is west, GHA is the best. Right, now towards the end I will try to show you conceptually the relationship between longitude, GHA and LHA, but for now just remember this rule of thumb to calculate your LHA from your GHA applying the longitude. Okay, so this is the rule of thumb you have to remember. That's a terrible one. So longitude east, GHA least, longitude west, GHA best. So if it's longitude east, GHA is least, you need to add your longitude to the GHA to increase your LHA. In this case, that's what your LHA is. Right, now I have named it east. Now in this context, naming the LHA is not important, but what you will see in my other videos is when you calculate the compass error and you're trying to find the true bearing by calculating the components such as A, B and C's, you will see that naming of the LHA becomes important there, because you use it to name the other components of the calculation. But in this context here, you don't have to worry about naming it, but I'll teach you how to name it, because there is another rule of thumb here. There is another rule of thumb, and the rule of thumb is that if the value of the LHA is between 0 and 180 degrees, then you name your LHA west. If it is greater than 180 and to 360, you name your LHA east. Alright, so later on when I show you conceptually the relationship between longitude and GHA and LHA, you will get a better idea of why it is so. Alright, for now just remember this rule of thumb. Alright, so I have this rule of thumbs written on the screen here so that you can remember it, write it down. So these are the two rule of thumbs that we use here. Alright, so you got your LHA. Now we need to go back to the nautical almanac and find the declination value for 2100 hours for the sun. Alright, so once we go back into the nautical almanac page 2100 hours. So right next to the GHA is your declination value. So if I zoom in here, you can see that the declination value is 9 degrees 5.4 minutes south. Right, you see 5.4 here, but you can see the 9 degrees here. You can see the south here, just in case you were wondering where I got my 9 degrees and 5.4 south from. So that's your declination value. But while you are here on this page, note down a couple of things. The first thing that you note down is that as you go from 2100 hours to 2200 hours, you can see that declination is decreasing. This is important because now you got to apply a correction to this declination value to get the declination for 2100 hours 16 minutes and 4 seconds. So if the declination is decreasing to the next hour, the correction that you obtain needs to be subtracted from this value. So this is the declination value, 9 degrees 5.4 is for 2100 hours, right? So you need to apply a correction. Now what is the correction? The correction is called D correction, but this is not the value you apply. You use it and go into the increments page to find the D correction value. So this is the D correction value to go into the increments page. So the D correction value here is 0.9. So these are a couple of things that you note down. So firstly, we note down the value of the declination here, which is 9 degrees 5.4 minutes south. You note down that the declination is decreasing to the next hour, and you note down the D value. So with that, we go back into the notes page, and this is what I have here. Declination is 9 degrees 5.4 minutes. And my apologies, such a big shift. Here you go. The D value that I got from the bottom of the nautical almanac was 0.9. Now it's a negative sign because like I said that it was reducing, so it needs to be subtracted. Now where did I get my 0.2 from? Now I use this 0.9 to go into the increments page for 16 minutes. Alright, and this is where I go back. So I need to go back here and I go back to the increments page. Right? Alright, takes a few goes. Now if you see the column here, it says V or D correction. Right? Now this is where you take your D value, you go down the right hand side column, and you see the D value is 0.9 here, the one that you got from the bottom of the almanac page on the 25th of February. Next to it is the D correction value, and that is 0.2. So you use this value 0.2 and apply it to a declination. Alright, so you go back and see, this is what I've done. I've applied 0.2, and that's how you get your declination value for the sun. And this is for 2100 hours 16 minutes and 4 seconds. Alright, so the principles pretty much remain the same for the planets and the stars. I'll take you through them as well, but the principle remains the same except for a couple of corrections here and there. Alright, so remember these rule of thumbs, remember the principle that we use to apply for declination correction and obtaining the LHA from the longitude and the GHA. And with that, we'll go into the next example for the planets. Now the planet example, the date and the time is same. I need to go back to the 25th February nautical almanac page to get the GHA value, alright, for 2100 hours. So it's the same principle like we did for the sun, except that now we go into a separate column. So this is planet and this is Jupiter. So if I go back out from here and I go into the nautical almanac page for 25th of February, I need to erase the rest of the stuff. Alright, there you go. Thanks for bearing with me. I'll erase the rest of the stuff here so that you guys don't get lost here what I'm doing here. So you can see that the planets column is given for Jupiter, of course, is given here, right? The principle remains the same. You go down the 25th February date, and this is the 2100 hours. And if you see, if you really focus on the 2100 hours, and if I zoom into the value of the Jupiter here, your declination value, sorry, your GHA value is 303.24.3. Right? While you are at it, or while you are on this page, note down the declination value as well, because now you know the rest of the stuff. So you just note down the declination value as 7 degrees 14.9 minutes north. Alright, so 303.24.3 and 7 degrees 14.9. 303.24.3 and 7 degrees 14.9. So you have 303 degrees 24.3 here. I have noted down the declination value well before 7 degrees 14.9. Alright, we go back to the increments page now. I'm doing two things at a time. Alright, so because you know the principles already, so I'm just trying to save some time here. So but I think I might confuse you here, so let me handle the GHA first, or the LHA first, and then I'll go back to the declination, right? So we've got the GHA value now, and we need the increment for 16 minutes and 4 seconds for the planet. So you know what to do now. Just go back into the increments page. I need to move out of this page here, go back into the increments page for 16 minutes and 4 seconds. It's the same as planets. You can see that the column remains the same, and that's why it's still 16 minutes and 4 seconds. The sun and planets column is the same, the value is the same. 04 seconds, it's 0401. All right, so I can go back out of here, go back here, and 4 degrees and 1 minute is what I have here, right? So now I will add this value because it's an increment value. I told you before, increments are added. An additional correction for the planets is a V correction value. Now what do we get? Now where do we get this V correction from? Alright, to get this V correction, we need to go back to the nautical almanac for the date of 25th of February, and I can show you from where I get that. Alright, so what we do is we go back here. We need to move out of this page here and go back in the nautical almanac here. Sorry about this to and fro. This is the best way I can show it to you. So what you see here is that for the planet of Jupiter, if I can show you here, is that there is something called V correction at the bottom of the page of the GHA, right? So if you see here, I'll highlight it to you. At the right of the bottom of the page is your V correction as 2.8 and also your D correction as 0.1. Alright, so with that V correction of 2.8, you need to now go into the increments page, and for 16 minutes. So for a V correction value, so you can see the V and the D's are given together, and this is your V and D's, right? Your V and D correction. So this time you need to find it for 2.8. You can see 2.8 is here. This is your V value, 0.8. This is the correction that you apply to your GHA when it comes to planets, and this is what I've done here. I've got this correction here. This is added as well. This will be 26.1. Alright, so let me erase it and write it properly so that you guys don't get confused. 26.1, so this will be 2 as well. Right, so if I add it, you will get 307 degrees 26.1 as the corrected GHA. You apply your longitude with the same rule of thumb that I taught you before. Longitude east, GHA is least, so you will add your longitude to the GHA. In this case, the LHA becomes greater than 360, and that cannot be the case. So if LHA is greater than 360, is here, you need to subtract it from 360. Alright, because LHA cannot be greater than 360. So if it is greater than 360, you will need to subtract it from 360 as I have done before. So LHA cannot be greater than 360 degrees, and that's how you get your LHA value. I have named it west again as per the rule of thumb. If it is between 0 to 180, if it is between 0 to 180, then of course you name it west. Alright, now I'll come back to the declination value. You all know where we got the declination from. It was next to the GHA. You know where I got my D value from. It was next to the V correction value at the bottom of the page. In this case here, we go back to the nautical almanac for 16 minutes to get a D correction value. This is a D value, and we need to get a D correction value for 0.1 for 16 minutes. So if I go back here for 0.1, you can see that the value is 0. Right, so there's lots happening here, so you guys are probably getting confused with all these values that are being highlighted, so I'll take off all these values. All right, just keep this here. So you can see for 0.1 it's 0. So I'll go back here and I'll apply the 0 here, so it's insignificant now. In this case, it doesn't matter whether it's plus or minus, but if it was decreasing, you would add it. If the declination was increasing to the next hour, you would add it, and if it was decreasing to the next hour, you subtract it. You remember the concept, right? So in this case, of course, it's 0, it doesn't matter, so it's insignificant. So the declination that we get for the planet is 7 degrees 14.9 minutes north, and this is a planet, right? Now similar concepts again. This time there is no V correction, but there will be an additional correction called the SHA, and we'll see how we get that one from. Alright, so the star in this case is Canopus. This is an example of a star example, and we need to find the LHA again. For 25th of February is the date, and if I write down the time is 1621 hours. I'm sorry, not 16 hours, but 2100 hours and 16 minutes and 4 seconds, and you need to find the GHA value of, or the LHA value of the star and the declination value of the star, right? So it's for Canopus. So let's go back into the nautical almanac, and I'll go back. So I need to get rid of a little bit of all these markings, otherwise you guys are probably getting confused with all this that is happening here. So I'll get rid of all these markings here, right, and I'll start fresh for the star. So the star, as you can see, there is nothing called star, but what you have here in the extreme left hand column next to the GMT column is something called the Aries, and this is what we use for the star. So this is the column that we use. So we have our 25th February here, we have our 2100 hours here. For 2100 hours, your GHA is 110 degrees 4.1 minute. That's the one that we take, right? We go back and we go back here. 110 degrees 4.1 is a GHA value. We again need the increment value, and we go back into the increments page for 16 minutes and 4 seconds. I need to move out of this page, go back into the increments page for 16 minutes and 4 seconds. If I can, bear with me, thank you. So 16 minutes and 4 seconds again. This time you go down to the Aries column, and for Aries you find out the increment value, which is 4 degrees 1.7 minutes. That's the value you take. All right, so let me get rid of the rest of it. 4 degrees 1.7, and I move out, I go back here, and that's what I have here as the increment. Increments are always added, so you will add to it, and that's the GHA corrected, GHA Aries corrected, right? Now here you have to apply an additional correction before you apply the longitude straight away, and that's called the SHA, SHA star. SHA stands for sidereal hour angle. Alright, so what we do is we will apply the SHA of the particular star, Canopus, and to do that we go back into the nautical almanac for the date of 25th of February. We move out of the increments page, we go back to the nautical almanac page, and you can see that somewhere here, let me show you where. Alright, somewhere here is the stars, right? Switches back to black all the time. So here, somewhere here is the star, and this is the SHA, and this is the declination. So let me erase it so that you can see it again. So this is the star right in the center here, right? You can see it, and then you have got your SHA and your declination values here for each and every star. This is in alphabetical order. Now what I need it for is a star called Canopus, and Canopus is here, and I have got my SHA value and my declination value right next to each other, so I can note down both of them. The SHA value is 263.59.1, and the declination value is 52 degrees 42.1 minutes south, right? So I go back, write it down. I've got my SHA value here, and I've got my declination here. Now I can finish off with the declination, because when it comes to star, there are no decorrections required. Star is too far to have any decorrection values. The rate of change is very slow, so the declination is very slowly changing. Alright, so that's why we just straight off note off, and we can finish off with the declination. Regarding the SHA, SHA is always added to the GHA irrespective. So you always add the SHA, never subtract it. Now once you add it, you can see that the value comes out to be more than 360. Alright, so you can straight off subtract 360 from here, or you can wait and see what to do with the longitude and then subtract 360 later. Now in this case, because your longitude is east, and you know the rule of thumb, longitude east is GHA least, and since you will be adding the longitude, your total LHA star value, this is how we write LHA star, comes out to be 454 degrees 29 minutes. Now since this cannot be more than 360, cannot be more than 360 degrees. Right, you subtract 360 from here. You could have done this, subtraction at this stage as well. It would have been the same thing, but we waited and we added the longitude because it was to be added, and then we subtracted 360, and you will get the same result, and you get the LHA. So that's how it is. Pretty much it's the same principles, except that with star you have an additional correction called SHA. With planets you have an additional correction called the V correction, which is applied to the GHA. And with sun, of course, you saw that the corrections are the basic corrections there. So go through these videos, go through these different examples again, and see what are the corrections and how do they differ from one another. You need to go a bit back and forth with the nautical almanac, as I have. But before I finish off this video, let me show you the relationship between longitude, GHA and LHA, as I promised before. And for that I need to make a circle, and my apologies if it looks really ugly, but I'll try my best here. Alright, so if you make a circle here and imagine this to be the spherical, or the celestial sphere of infinite radius, right? Now I'll start with the GHA. The GHA is the angle between the Greenwich meridian and the celestial body, right? Now in this case here, well, here the GH is more than 360, so I will not use this example here. I'll use the example from, well, here 307 degrees is the GHA. So let me take this example here of the planet, and here what we have done is basically, let me write down the values of the or let me take the first value itself. Okay, sorry for all this confusion. So for the sun that we calculated, let me write down here what we did. So the GHA, corrected GHA value for the sun from the first example was 135 degrees and 44.6 minutes. The LHA value was 212 degrees 8.7 minutes, and the longitude was of course 76 degrees 24.1 minutes east, right? And the LHA was of course east as well, because it was more than 180. Now this was from the sun's example, right? Now if I need to conceptually visualize it, GHA is the angle between the Greenwich meridian and the celestial body, and it is measured westerly, all right, from the Greenwich, measured westerly from the Greenwich meridian. All right, so if I imagine this to be the Greenwich meridian, and if I go westerly and measure 135, it will be somewhere here will be the celestial body, and I'll draw a sun here. Now if I measure this angle westerly, this value here is 135 degrees. That's your GHA, 44.6, right? That's how your GHA looks. Now if you need to know what is LHA, LHA is now the angle between the celestial body and the observer on the celestial meridian. So the observer is you on the ship, right? And this is also measured westerly, but from the celestial body. So let's say your LHA is 212 degrees 8.7 minutes. So what I will do is I will measure 212 from here. So if this is 180, I've got another 45 to, so somewhere here becomes your body, or it's you on the ship, the celestial observer, right? So this measured here westerly is the LHA, and you can see here in this case your longitude is 76 degrees 24.1 minutes east. So you can see the longitude is actually the angle between Greenwich meridian and the observer, and this is measured westerly or easterly depending on whether you are on the east or the west of the Greenwich meridian. You can see here in this case you are on the east of the meridian, right? And that is why this is the relationship between and that's why your longitude here is 76 degrees 24.1. And if you viewed the other way around, if I had drawn the longitude earlier, you would know why the body is up there, why the LHA is up there, and why the LHA is east. So you get the concept or the idea between LHA, the longitude, and the GHA. Right, so go through this video again. I will make some more videos on theories regarding LHA, GH, and longitude. So if you found this a bit confusing, don't be disheartened. I will put up more videos, more theory, but right now I was focusing more on the calculations. So go through these videos multiple times, see the corrections that we applied to the planets, to the star, and to the sun, and how did we get the LHA and declination. That's more important. Remember the rule of the thumbs that we used and the concepts that we used to get it. All right, so I'll catch you soon with another